We are studying motion in one dimension, and this is note number 5. We'll continue learning about velocity. Let's understand more about velocity. Okay, we have already understood about speed. Let's understand more about velocity. Let us say that there is a car moving on a highway and it is moving towards east. You can look at the compass on your screen and you'll understand which side is east, west, north, and south. So in this illustration, the car is moving eastward. And let's say that it is moving at 100 km per hour. Okay. So the velocity of a body is the distance traveled per second by the body in a specified direction. 2 points to remember: distance travel and specified direction, right? That's what velocity is. And by this we can define that the rate of change of displacement of a body with time is called velocity. Okay, the rate of change of displacement of a body with time is called velocity. And velocity is a vector quantity which is represented by the symbol u or v, lowercase u or v with an arrow sign on top. We have learned how to write the symbols when we're studying about vector and scalar quantity. Now you remember that in velocity, both its magnitude and direction must be specified. Let's see an illustration. Let's say that there are two SUVs traveling on a highway. You will see the compass on the right hand side of your screen. Now these two SUVs are traveling in which direction? They're traveling eastward, right? They're traveling towards east. And you can also see that these two SUVs are traveling at the same speed. The first SUV is traveling at 80 km per hour, even the second SUV is traveling at 80 km per hour. So what is same here? Speed is same and direction is same. So in this case, we say that two bodies are moving with same velocities, where speed and direction is same. Let us see another illustration. Two SUVs, both moving in the same direction, but you see that the speed at which they are traveling is different. The first SUV is traveling at 100 km per hour, second SUV is traveling at 80 km per hour, right? The speed is not same. Speed is different speed and same direction. Let us see another illustration here. Two SUVs again. Now both of these SUVs are traveling at the same speed, 80 km per hour, but they are moving in opposite directions, right? The first SUV is moving eastward and the second SUV is moving towards west. I hope you understand it, right? Now in these two cases, we say that the two bodies are moving with different velocities. Okay, now I hope you understood the difference between two bodies moving in same velocities and different velocities. The SI unit of velocity in meter is meter per second, and the CGS unit of velocity is centimeter per second, same as speed. Okay, the SI unit and CGS unit is same. Now let us understand what is uniform velocity. We have already learned what is uniform speed. Let's say that you are cycling, or there's someone cycling. Okay, this is the initial point where time is 0 second, distance covered is 0 meter. Now this person is traveling, this person has covered 5 seconds. In 5 seconds it has covered 10 meters. Okay, 10 meters. And in again another 10 seconds, the person has covered 20 meters. Okay, and looking at the compass, you understand that this person is cycling westward, towards west, right? Uniform velocity, right? Even the time interval is same and the distance covered is same. Time interval is 5 seconds and distance covered is 10 meter. So if a body travels equal distance in a particular direction in equal intervals of time, then the body is said to be moving with a uniform velocity, right? Equal distance in equal intervals of time. So the displacement can be calculated by S is equal to V into T, and uniform velocity can be calculated by V is equal to S divided by T. Let's understand about non-uniform or variable velocity. Looking at the screen, you will see that there is a football, right, which has traveled at particular distance in particular time. It has moved eastwards. The initial time is 0 second, and then in 1 second, 2 seconds, and 3 seconds, right? You see that the time interval is same, right? Time interval is equal. 1 second, 0 to 1, 1 to 2, 2 to 3 is 1 second. So there's equal intervals of time. Now let's see about how much it has moved. Okay, the displacement. Initial point 0 meter, then in 2 seconds 3 meter, and in 3 seconds 6 meters. And of course in 1 second it has moved 1 meter. By this we see that the distance traveled is not same. All right, it's unequal. In 1 second it is traveled 1 meter, again in 2 seconds it is traveled 3 meters, in 3 seconds it is traveled 6 meters. So the distance covered is unequal, but we know that it is moving in a particular direction, right? So by this we can understand that if a body moves unequal distance in a particular direction, like in this example it is the ball is rolling eastward in a particular direction in equal intervals of time, if a body moves unequal distance in a particular direction in equal intervals of time, right, then we would say that it's a non-uniform or variable velocity. Let's see another illustration. This is a football that is moving not on a straight path. Okay, initial time 0 second, it has traveled 0 meters, and in 1 second it has traveled 1 meter. Now you see that in the start it is moving towards east. You can look at the compass to understand it, that you'll see on your screen. And after traveling 1 meter eastward, the direction of the football has changed. It is moving southeast, right? 2 seconds, 2 meter. Traveling towards 3 meter, it has changed its direction towards south. We have seen one illustration. This is the second illustration. Or if a body moves equal distance, right? You see it's moving at it has moved equal distance. 0 meter, 1 meter, 2 meter, and 3 meters. So the interval of distance is 1 meter, equal, in equal intervals of time. Even time interval is same. 1 second is the time interval. But what is different here? But its direction of motion does not remain the same. You see it has started moving eastward, then it moved towards southwest, then it has again changed its direction towards south. So the direction of motion does not remain the same. In this case, we will term this as non-uniform or variable velocity. Non-uniform or variable velocity. I hope you have understood this with the illustrations here. Now let's see an example. Another example, motion of a body in a circular path, even when it is moving at uniform speed, is with variable velocity or non-uniform velocity. Now this was one of the example, but it has not moved circular. You will see on the screen that there's a body moving in a circular motion, but you see that the velocity is variable, right? Different directions. So when the directions are different, we say that the velocity is variable. Velocity is not same. Okay, I hope you understand this. Let's see about instantaneous velocity. Now if a body moves with variable velocity, then the velocity of the body at any point, at any instant, okay, any point, is called its instantaneous velocity. For a body moving with a variable velocity, remember I gave illustration of which type of velocity will be variable velocity. To find instantaneous velocity, the formula is same like instantaneous speed, distance traveled in a short time interval divided by time interval. This is how we find instantaneous velocity. Now average velocity is calculated by dividing displacement and total time taken. This is how we find average velocity. Let's see some more examples, okay, to understand this. Let us say a stone is thrown vertically upwards from a point, and let us mark that point as A. Okay, now if a body starts its motion from point, and after some time, after reaching a height, what happens to the stone? Again it starts falling down vertically. Where? At the same point from where it started, right? At same point from where it started. In this case, the displacement is 0 because the starting point and the ending point is same. So the displacement is 0. The average velocity also will be 0, right? The average velocity also will be 0. But the total distance traveled is not 0, right? Previously I have explained to you about this. But the total distance traveled is not 0, right? It has covered some distance to reach that height and again come back. So the total distance traveled is not 0. Therefore the average speed also will not be 0. Okay, I hope you understand this. You can just go back through the video and see it again. Let's see another example. A body moving in circular path. Okay, a body moving in circular path. It starts from an initial point, right? Now you see that the directions are not same. Okay, it has started from one point and again it has reached back into that same point. It covers equal distance in equal intervals of time, right? You see it is marked as D, A, B and C, A, B, C, D. Covers equal distance in equal intervals of time. Here the speed is uniform because the time taken to cover D and A to B and B to C and C to D is same. But because there is continuous change in the direction of motion, right? You can see that there is continuous change in direction of motion. Its velocity is changing, right? Its velocity is variable. It's not uniform, it's variable because there is continuous change in its direction of motion. So the instantaneous velocity and the instantaneous speed is not 0. Okay, the instantaneous velocity and instantaneous speed is not zero. The displacement for one round is 0. Right, I hope you understood this. Let's say that it has started from the point D, and when it makes one circle, it comes back to the same point from where it started. So the displacement for one round is 0. Therefore, average velocity will also be 0. Okay, therefore average velocity also will be 0. But the average speed, you know that we have talked about this, how to find the circumference of a circle, 2 pi r. The average speed will be calculated by 2 pi r by t, capital T, where r represents the radius of the path, circular path, and capital T is the time taken in one round. This is how we can calculate the average speed when a body is moving in a circular path. Here are the distinctions between speed and velocity. You can study it by yourself, go through it and remember it. I hope you have understood this part of speed and velocity. Keep studying and keep learning.